Well, I don't know that I need to be up here since James did such a great job. Long story short is IME works really well for diverse I/O. So my name is Jesse Hanley. I'm a sysadmin at Oak Ridge National Lab as part of NCCS, home of Titan, and our big storage target is Atlas. It's all DDN, about 32 petabytes usable, Lustre file system, completely nearline SAS. One of the things we did when we designed Atlas was we have a test and deployment system that's just a single rack. Allows us to test firmware updates, software updates, pretty much anything we throw at the center, the TDS gets it first. So I've been using, these results are a few months old, but we got an IME white box from DDN to test against our TDS to see what type of improvements we'd see. Here's a layout of how that's structured. I think everyone can read that. Basically, the SFA12K is the TDS, and that runs through Scion, which is our scalable I/O network. It's basically our FDR SAN. And we have that connect to a compute cluster through some Elnet routers. We tied the 4 IME Demo Nodes into the compute cluster and used a subsection of the compute nodes as clients, dedicated clients to it. These are just the basic specs of the IME Demo Nodes. As none of the NVMe, no NVMEs, but the caveat here is we had to use a ConnectX-3 because of some of the limitations in our site. There was a Lustre version mismatch on map on demand credits and InfiniBand, so we had to run a older generation IB card. Since then, that's been fixed in Lustre side, and we've moved to using the 2 single port cards. When we got the white box, we were using IME 0.8, and since then we've worked pretty close with the IME team to test 0.9 and the release candidate of 1. The GA version is installed, but these tests haven't been rerun against it. There's 4 major things we wanted to get out of it. What type of, do we see anything in the metadata? When we first started our test, we knew that the IME didn't do anything on the to cache MDS request. So we were like, okay, what type of hit are we going to see? The big interest was the bandwidth impact. What type of benefit do we see to our IOs? Workflow impact. How new technology is great, but if it's completely unusable to users, then it's nothing. It's harder to get users to use it than aren't power users. And then the quality of service is how resilient is IME and how much of an impact does it have on the administrator's job. Like I said, the early generations IME code didn't have metadata caching and performance as a concentration. So we did see a hit there, but that's was expected. But these are the bread and butter for my presentation, is really wanting to focus on the bandwidth performance increase. So this is the 4 nodes writing to a mix of, this is all IOR, but it's the increase in read performance is pretty drastic. I don't know if anyone can actually make out what that is, but it's, that got cut off. Okay, that's 4K IOs for 4 threads, so 1 thread per node. 4K IOs for 8 threads, so up to 8 threads per node. That's why the graph kind of staggers there. But the big thing here is any relatively, so at the OLCF, we've recently done some pretty heavy I/O profiling on our codes, and we noticed there's basically a bimodal distribution of IOs at 32K and 1 meg. And there's a huge spike in 32K writes and a huge spike at 1 meg. We don't have much in the middle. And the dark green line down at the bottom is writing to the TDS directly, just using Lustre client. And then the IME, I don't know that it's been touched on, it's basically has 2 modes of operation. You can either write MPIO, use the Romeo driver to write to it, or use a fuse mount to write to the IME. The sequential write, again, we see quick benefit scaling up. The lower end here, we believe was part of, these are on the 0.9 release. So some of these have been increased since then. But I don't have enough data to actually present on those yet. But again, across the board, the IME is much more performant than the parallel file system. And this is good I/O, the best case scenario. This next graph looks a little scattered. So this is basically a random read of from the IME. The problem was none of this data was staged into the IME beforehand, and this is the best out of 3 iterations. So you get the bottleneck of having to reach the parallel file system, as so that gets pulled into any of the IME calls. It wasn't that it wasn't staged. We fleshed it out manually just to see like a worst case scenario to the IME. But my favorite statistic is this graph. It's 4K random writes and up. The IME is orders of magnitude better than writing to the parallel file system. We've got some bio users, and especially new projects that come on, that their codes aren't as tuned as some of the veteran projects. And we see huge spikes in metadata performance because someone's treating our file system like a database. But these 4K writes just kill some of our site's performance. The big problem is, though Atlas mainly serves Titan, it's a shared resource for the rest of the resources in OLCF. So having a job on Rhea, one of our compute clusters, or our DTNs transferring at some suboptimal rate makes pretty much the center work at a random, it looks random on disk, which I thought was a pretty neat benefit of the worst case scenario still being amplified and made better with the IME. As I mentioned before, the workflow impact, there's the fuse mount and the Romeo driver. I personally love the fuse mount now, and I never thought I'd say I love fuse, but just having another mount and not having to tell my users that, or some of the other staff that got on here is like, oh, no, it's the same path you've all used, just don't worry about it, just write to it, was really nice. And then working with the IME team, they were able to get us an open MPI build for it. Then looking at quality of service, because of the dependency on the MDS and the build we were using, back-end file system failures cause failure on the IME, which is to be expected. And then the earlier releases of the software had dependency issues between the, like within the cluster, but those have been knocked out. And those issues. We did run into a pretty interesting bug, which was in one of the earlier releases of doing these 4K writes and 4K read benchmarks on the IME for hours and hours and hours. We would fill up commit logs and cause issues. And I've never seen a user do a file system like that, but benchmarks. But the IME guys were able to knock that out. One of the issues that I think has been addressed now in the GA is using backing multiple file system or plans too. Like one of the issues we have is we have a dual namespace, so backing an IME for like Atlas 1 and Atlas 2. And then looking at the administrative overhead, I personally love metrics, and the amount of information I was able to find of what bucket I/O was going into, what files were hot on the cache, being able to pull that through was really nice to me, and having that information to be able to like pull that information down. Yeah, and the API is like fairly well documented, especially nowadays. I don't see a lot of good API documentation. And again, like mentioned before, being able to prefetch files into the IME as part of your job staging, and having commands do that is pretty neat. Like I said, this was for the older release on IME Whitebox. I think we're looking at getting the 14K form factor and rerunning some of these on some of our other compute clusters. And then we'd like to try, since we're planning on having a rather large GPFS, seeing like what happens, what type of interactions that should look like. And once again, I'd like to thank the IME team. They put up with a lot and a lot of emails, especially Ryan, engineer. I guess that's about it for me.